Okay, we have two objectives for this video today. The first is to identify several forms of energy, and the second is to distinguish between kinetic and potential energy. So what is energy in the first place? Okay, to quote an American theoretical physicist, Richard Feynman, in physics today, we have no knowledge of what energy really is. It's kind of a disconcerting thought because, again, we don't know what it is, but we do know what it does, and that's what we're going to focus our studies on. Okay, so let's begin. There's 9 different main types of energy that things go into. Okay, sound energy, electrical, light, thermal, nuclear, and chemical energy. On the bottom, we have what we classify as mechanical energy, and these bottom 3 are the ones that we're going to focus on. We have gravitational potential energy, kinetic energy, and elastic potential energy. Okay. Mechanical energy is the energy something has due to motion or position of an object. There's 2 forms of mechanical energy. There's kinetic energy and there's potential energy. Both of these added together gives us a total mechanical energy. Okay, so when we start to analyze our situations, we're going to look at both of those types of energy. But first, let's break it down into what each of those are. If an object is moving, we know that it has energy. Okay, you do need to be careful because the opposite of the statement isn't always true. Just because something has energy does not mean it has to be moving. If it is moving, though, it has kinetic energy. And kinetic energy is simply defined as the energy of motion. Kinetic energy depends on 2 things, the object's mass and the object's speed. Okay, in the middle of your screen is the equation for kinetic energy. So kinetic energy is equal to 1/2 the mass times the speed squared. Okay, why am I saying speed instead of velocity? Because direction doesn't matter when we talk about energy. Since that v term is squared, if we were moving in the left direction, by the time we squared it, the negative would disappear anyways. Kinetic energy is directly proportional to the mass of the object. So if I have twice the mass, I'm going to have twice the kinetic energy. Okay. Kinetic energy is directly proportional to the square of the object's speed. So if I'm moving twice as fast, I'm actually going to have 4 times the amount of kinetic energy. Kinetic energy is a scalar quantity, so that means no directions. That also means no vectors. Okay, it's just an amount, so whatever value we get is the amount of energy it has. Units of energy are joules. Okay, notice what it breaks down into. Okay, a joule is actually a kilogram times a meter squared per second squared, or also known as a Newton meter. Okay, let's tie this in with what we've been studying. Okay, momentum is how much quantity of matter something has. Kinetic energy is how much energy a moving object has. Okay, do you remember the bullet and the baseball problem that we dealt with momentum? Okay, when we found the momentum of the bullet, you actually got an answer of 4 kilogram meters per second. When we found the momentum of the baseball, we got 8 kilogram meters per second. Okay, a baseball, in terms of momentum, is going to be harder to stop. Okay, a baseball is going to have the greatest change in momentum. But if we think about this from an energy standpoint and use our equation for kinetic energy, okay, substituting the values, the bullet would have a kinetic energy value of 774 joules. The baseball would have kinetic energy of 160 joules. So see how they're actually measuring different things. Okay, if we think about a bullet, we know a bullet is going to do more damage to us if it hits us. That's because it has more kinetic energy. A baseball, however, is going to have more momentum traveling at those given speeds and would actually be harder to stop. Okay, the next form of energy that I want us to talk about is potential energy. By definition, potential energy is just stored energy or stored work. We'll talk about work next class period. There's 2 types of potential energy. Okay, one of them is gravitational potential energy. Gravitational potential energy is energy that an object has due to its position or arrangement. Okay, notice from the equation below, the position that we're referring to is the height of the object. GPE, or gravitational potential energy, is equal to mass times gravity times height. Okay, gravity, since we're on the Earth, again, is going to be 9.8. Notice how those variables are going to tie into each other. The twice the mass would give us twice the gravitational potential energy. Or if I move something twice as high, we're also going to have twice the gravitational potential energy. The second form of potential energy is elastic potential energy. Okay, think about stretching a rubber band out, or think about your garage door spring. Okay, elastic potential energy is energy that occurs when an object resists being stretched out of shape. Okay, a spring resists being stretched out of shape. So does a rubber band. Elastic potential energy depends on what we call a spring constant, that's the letter K, and also the distance that it's going to be stretched. X would represent the distance it's going to be stretched. The harder it is to stretch, the higher the K value will be. Again, the K value is a constant and it depends on the object in question. Okay, for finishing out the semester, those are the only types of energy that we're going to focus on. So again, we're going to focus on kinetic energy, the energy of motion, and then potential energy, which is energy due to position. And there's two types of potential energy, gravitational potential energy and elastic potential energy.